Okay, let's look at the 9.1 quick check. Okay, when I look at nitrogen, I know that nitrogen is in family 5, has 5 valence electrons, and so I know it's going to take one of each of those valence electrons to hook on my fluorine. So 1, 2, 3, and that means I have 2 left over, so I'll put them on the central atom. I'm going to go ahead and put in my lone pairs for fluorine before I forget. And look at that, that's a steric number of 4, 3 bonded atoms, 1 lone pair on the nitrogen, and 4 means it must be sp3 hybridization. Okay, the 4 is going to be tetrahedral, but because there's a lone pair, then this is going to be trigonal pyramidal. The bond angles here, pretty much 109.5, but because of that lone pair, we could say maybe it's 107 degrees. That's fine. Definitely polar. Okay, because there's nobody to balance off that one side. So if we see this, 1, 2, 3, and there's a lone pair up here. So if there is a bond dipole, they're all going to be pointing in one direction. Okay, XeF4. So the idea here, Xe, we know it has 8 valence electrons. It's going to take 4 of them to hook on the fluorines. That leaves 4 left over, which will be 2 pairs. So I'll put them here on the central atom. Adding in my lone pairs. Okay, so the steric number there is going to be 6. Okay, but those 2 lone pairs are opposite to each. Anyway, 6 is D2sp3. And the shape there is going to be square planar. Because as we're going to say was that the lone pairs are going to be opposite to each other. So it's, really going to be 1, 2, 3, 4, lone pair up and a lone pair down. So since these are all going to be at 90 degrees from each other, then it's going to be nonpolar, because any bond dipole, okay, those 2 would cancel each other, those 2 would cancel each other, so this is going to be a nonpolar molecule. Okay, when you get to SF4, okay, again, sulfur has 6 valence electrons, so we're going to go 1, 2, 3, 4 of them to hook on the fluorines, and that leaves 2 electrons, which would be 1 pair. So steric number is 5. Okay, it's going to be DsP3. And let me go back and put in my lone pairs. And this time I did dots just because I felt like it. And the shape of that is going to be seesaw, because we're talking about 1 up, 1 down, 1 out this way, 1 out this way, and then a lone pair. Lone pairs always go, for steric number 5, they always go in the equatorial positions because they have more space, and lone pairs repel more than bonding pairs. So the bond angles here, they're going to be some of these that are 90 degrees, and there are going to be some of these that are 120 degrees. Slightly less because it's lone pair, but that's fine. And I would definitely say this is yes, this is going to be polar, because these 2, okay, those 2 bond dipoles would cancel, but there's nothing to cancel the sideways one. Okay, so around the equatorial position, so definitely going to be yes. Okay, Hydra cyanide, we can draw those 2 different ways, and they both follow the rules. So we say, well, what are the formal charges? So formal charge, we start off with the number of the electrons they normally have, so what family they're in. So hydrogen has 1, carbon has 4, and nitrogen has 5. Okay, just because they're in those families. And then how many do they have in this structure? So in this structure, we say, well, hydrogen has 1, because it shares, the pair of electrons, it gets 1 of the shared. Carbon is sharing 3 pairs on one side, 1 pair on the other side, so it's going to have 4, gets half of all the shared electrons. And nitrogen, okay, has 1, 2. The lone pairs count totally for nitrogen, and half the shared pairs, so that's going to be 5. So that's going to be 0. Okay, so I'm pretty much going to say, okay, that's going to be our stable structure, because everybody is a formal charge of 0. Okay, let's check the other one. Okay, hydrogen, again, same situation, so it's going to be 0. Okay, nitrogen in this picture, okay, has 1, 2, 3, 4. It has 8 shared electrons. It gets 4 of those. So that's going to give it a positive 1 formal charge. And carbon, which normally has 4, in this case, has the lone pair plus 3 shared. 3 of the shared pairs, so it's going to be -5. So to be -1. Okay, so the fact that it's not 0, 0, 0, that's going against it. And if it was going to be positive and negative, the more electronegative atom is the one that needs to get the negative charge. and nitrogen is more electronegative, so it should not be positive. So this is not going to be a stable structure. So it's answer HCN. That's the quick check.